Hello everyone, good morning. Today we would like to present our solution for the Unilever's Engineers League, and our project was automated pallet feeding, and we'd like to start with introducing our team. Please meet sign name Muhammad Naim, Muhammad Mohamed Islam, and my name is Arif Zaman. So in this presentation we will be talking about first the analysis of Unilever's current engineering practice and overall vision, and then we'd like to present the analysis of existing operation as we had seen during the factory visit and the case study given to us, and then we'd like to talk about the proposed solution, the simulation of the proposed solution, and the benefits of the solution, and the cost analysis. Unilever is a company that is a company with a purpose. Their company vision is sustainable, digital, and biological. And they believe in sustainable engineering, digital engineering, packaging engineering, and safety engineering. And they are working relentlessly toward their vision of leading to the Industry 4.0 revolution.
Hello again, this is Mohammed, and I'm going to discuss about the existing operation at Unilever. So we can see first it's a manual operation, like there will be a stock of pallets and someone has to carry the pallet to the pallet feeder. So it would be a very time consuming process. We can see there are 6 processes. First, it will be loading from the stock, and the driver will take it to the buffer zone. Then the most wasting part is timing, because someone has to always check the feeder is empty, either is empty or is full, and shit.
It's okay.
And it takes around 20% of someone's daily.
Continue.
It takes the 20% of
your worker time.
Worker time, not time. It's shift. Yeah, workers shift. So we cannot say that it's very cost effective. And okay, then what?
Then next, done. এটা সুন্দর একটা ফরম্যাটিং দা করে একটা।
হ্যাঁ সেটাই।
Okay, ওইটা নিয়ে পরে কথা বলবো। Let's continue. Okay, this one is done. We'll talk about
Okay, let's see about the shortcomings, as it is manually operated and it takes too much time. So we can say the company has to give more labor cost. That's why we are planning to bring something that would be cost efficient. And as we saw in the previous slide, that it's manually processed and it takes more time. That's why we obviously can say it has less efficiency. Okay, the most important part is safety, as the pallets are very heavy and it's a big stock, and someone has to carry with the machine like a forklift. So there's a safety concern. Also, the forklifts, they are running. What is in the floor?
To and fro. It's a hard intervention.
Yeah, it's a hard intervention. And another concerning part is.
Yeah, that's what the last one.
Yeah, the last one.
Not the next one.
The last one, yeah.
Less pallet line due to the hard intervention, which is like not cost efficient. Okay, let's go to the next. We'll talk about.
So my next colleague will talk about the thoughts behind our new solution and other parts. Okay.
As we have already set the background where the current operation procedure is running with less efficiency and more labor cost, and we have the exact line of work that we have to automate. So as an engineer, the first step we try to do is like to brainstorm and to come up with a definitive solution that is compatible with the current engineering practice of Unilever. So at the beginning of our brainstorming, it was very obvious options that came in our mind. It's robotic arm. But we had to cancel out that idea based on the reasons that we have presented, which is the three-axis movement of a robotic arm takes a lot of space, and here in this particular case we will be working with a lot of high, exactly the term will be, stack of pallet. So when it comes to robotic arm to pull up at such height of pallets, it's kind of not safe, and also the existing floor plan doesn't have enough space for the installation. And last but not the least, it's hugely expensive. Then we thought about laser guided forklift. That didn't even seem to be a perfect solution as the current procedure involves AMR to bring them to the buffer zone. So to put the buffer pallet stack from the buffer zone to the feeder, the AGV has to communicate with the pallet feeder itself, which is a complex procedure to put into practice. So we were thinking of something more reliable, independent, and with a vision to Industry 4.0, and it should be feasible, compatible with the existing infrastructure in terms of the floor plan and everything. So we came up with the idea to present you guys with our solution, which is the automated pallet feeding station, including a intelligent buffer zone. So here you can see it's a 360-degree view of the station that we have designed. In no time we will be introducing you with all the parts and technical details that's involved in our simulation. So the whole system consists of basically around 6 parts. Here we have excluded the brain PLC itself, as we know the already existing PLCs has a lot of input and output terminal which can be integrated in this solution. So to cut cost, we can mention it or not. Okay, let's go. So the rest 6 part which has to be implemented to the current working station is the turntable conveyor, which is a very available option from like multiple suppliers. AMR conveyor interface. This is the most interesting part of the design itself, and we had a challenge where we have to receive the pallets from the AMR itself and then put it to our system. So I haven't seen so much solution, but there is a few, and this is the best of them, where we can directly dock our AMR to put it into the conveyor belt, and it is compatible with manual operation and also laser guided forklift as well. And the AMR here is from Milvas, as we have researched for our practicality of our solution. We have seen that Unilever has their supplying contact with Milvas, and this is the exact type of AMR that they supply. So our system is compatible with the AMR that they that are already being used by Unilever. And then comes the minor parts where we use sensors, and the buffer conveyor is a very regular conveyor with the programming itself, which makes it intelligent, and the cart conveyor to put it to the intelligent buffer itself. And last but not the least, we have considered the safety case as well. And the last cover of our safety is to keep the location detached as it involves the movement of like heavy objects by fans, which is already there in the system as well. So, continue?
Yeah.
Okay. So, here is a clear picture of how our proposed station, automatic pallet feeding station, align with the current floor plan. As you can see that this is the exact given floor plan in our problem description, and it's exactly goes with what we, with the current floor plan, and it fits perfectly. The operation area will be cleaner than ever, and the receiving end is very, very accessible for both manual and AMR operation. Coming from there, now we can talk about the operation flow itself. As we have seen in the first slides, that the current operation takes around 6 to 7 steps for the same flow to complete and to feed the pallet. But in our system, there will be two major steps, which is receiving the pallet from the AMR or from the manual, if it's manual operation, from the forklift itself, and then directly or indirectly feeding to the dispenser. And as you can see in the slide itself, there is two other steps involved in the procedure, but this is very internal and this won't affect the production time itself. So the two steps that we can see will be done by the brain PLC itself, which will be a logical analysis, and that will be done on the basis of the signal that it receives from the sensor that's in the specific place of our system, as you have seen in the picture already. And the intelligent buffer itself is just the place if there is already a pallet in the dispenser, and in line with the dispenser, the pallets will be placed to the intelligent buffer systems by the program itself. So to make it much more clear, here we have our simulation, and we have divided it in 4 different cases to make it clear. So my colleague will take over to familiarize you with these cases.
As an engineer, we believe that an idea is not an idea until it is implemented. That's why we try to do a real simulation based on the software factory IO, and we had imagined all the real possible cases of scenarios that could be during the operation, and I'd like to present that on a case-by-case basis. So in the case 1, we can see that if there is no pallet inside the dispenser, our AMR receiving section will take the pallet from the AMR, and then it directly goes through the conveyor into the dispenser itself. And then in case in case we need for one by one, then we can also do a continuous feeding.
This is 3.
Is 3?
Yes, this is
Continuous feeding. Skip. Three take the name.
number 1. এটা কিছু জানতে হবে। আচ্ছা, এই সিকোয়েন্সটা ঠিক নেই। It's okay, এখান থেকে ডিরেক্ট করলে হবে। Case 3.
Yeah.
Describe the time.
So here is where things get interesting. So instead of picking pallets from the buffer zone, this was one of the crucial part of our brainstorming process, which separate buffer zone would have taken a lot of spaces. So what we did is through the conveyor, we have made this in an intelligent system. So basically the conveyor belt itself would be the buffer area, so thus not needing any other extra spaces around. And how it works is, after collecting the pallet stack, if it needs to be sent to the buffer zone instead of the dispenser, it's gonna, through the turntable conveyor, go to the intelligent buffer zone through the use of the sensors,
And then
which has basically options for six stacks of pallet, holding six stacks of pallet at the same time. And lastly, um, if there is no manual intervention involved, then the system automatically detects if there is no pallet inside the dispenser, and then it can, from the buffer conveyor, directly be sent to the dispenser itself. And you can take over.
Okay, so let's say about the benefits of our proposed solution. We can say it's very simple because we think it's least complex and doesn't require extensive training for the workers and the manipulation of, to control it. And if we talk about the compatibility, it's based on the PLC, and also what I say?
anything.
Okay. It's controlled by the PLC, and it's perfectly fit to the existing infrastructure. Also, we can say it's a future upgrade to the IoT. What is it, IoT?
Internet of Things.
Internet of Things, and which is a part of Industry 4.0 roadmap. Okay. There are other feasibility, for example, competitive price and installation doesn't require any complicated procedure. Okay, and we also concerned about the safety because, not because.
Okay, আচ্ছা এখানে হচ্ছে আমরা শুরু করি প্রথম থেকে যে এভাবে শুরু করি যে as we have already seen the problem itself, the shortcomings and the solution that we have proposed, it's pretty much clear to everyone by now that our solution has much more benefit, and it already talked to you guys by itself. But yet again I want to mention that our solution is simple, compatible, feasible, safe and cost effective. Cost efficient or cost effective, or so it's effective in terms of complexity. It's the simplest solution ever possible. There isn't necessity of training anyone. This perfectly fits with the current practice of Unilever, where all the other conveyor belts are PLC based, so there won't be any other man force for the maintenance of the system itself. It will be just another sub-project of the existing infrastructure. The feasibility is that it's very individual. I mean, all the parts are such individual that they can be replaced, or there isn't any complicated procedure in terms of maintenance. And when it comes to safety, we have given it a very extensive thought, because coming from it, having the experience of working in a production environment for quite some time, I have seen how safety matters in a production environment. So we have put a brief thought about it, and we can manipulate the safety in a lot of different ways, and our system is compatible, easy to manipulate in terms of safety. For example, there is two main things. The main safety concern is that the height of the pallet stack can be affected by the speed of the conveyor belt. So with the help of PLC, it's just a few line of programming where we can manipulate the speed itself. And also, as this is an intelligent system and we don't need manual intervention, we can just simply make the height of the pallets stack half, and then there won't be any risk involved in this which will make it safety. So when it comes to safety, we do have options to iterate from this position with a very, very less amount of time investment. And the cost efficiency will be briefly discussed in the next slides itself, so you will have a clear idea by itself. So let's take.
So we have done a little research on the internet about the current suppliers of Unilever on different production area worldwide, and based on the data we have been able to gather from internet, we have put some approximate costs of the basic equipments that we might need, and that involves AMR conveyor interface, a turntable conveyor, and a curved conveyor, a roller conveyor, and some industrial sensors, which are widely available at from different suppliers, and
For industrial grade use.
so the cost analysis was a bit tricky, since we had to use proxy values as a method to calculate about the efficiency of our solution in terms of cost and time. During the factory visit, we had the information that a typical worker's shift 20% goes into the pallet feeding process.
So at least 20%. So
at least 20%, and so that
that brings us to the point that per shift it costs around 26 euro, and if we round it up to a month, it costs around 624, which gives us a total sum of 7,488 per year. And when we implement our proposed solution, we're gonna save the entire this amount to its entirety. So we're gonna save 7,488 euros per month, per year, and the efficiency of the system itself will be 10 times more than it used to be with the manual operation. And after making, the investment, this is the.
Okay. That being said, the investment payback period is very low, which is 1 year, 1 month. So basically, within installation of 1 year, we're gonna get the money. But this is just a consideration in terms of money. As our solution is more efficient and faster than the conventional methods, so it's gonna save a lot of time as well, and the overall production capacity will be increased, as we have approximated in at least 10 times. Also, additionally, there is depreciation cost, which is very high in case of complex machinery such as robotic arm or automatic guided vehicle, which we don't have basically, because a conveyor belt or things like that are very sustainable for long term, and little parts can be replaced easily, and overall the depreciation cost is very much lower than the alternative methods.
And the company will start earning revenue from this installation of our proposed solution from the very next year of its installation. So we are pretty much looking forward with the solution to be the best one. And now at this point, we welcome questions and thank you for your attention. So it's been 23